Good day to all the viewers. My name is Nodi Yambo, and I'll be your presenter for today's lesson, which is all about cells and batteries for the grade 9
Technical Studies B
learners. A cell refers to a device that generates electricity. This lesson, we shall share more on the light of cells and batteries. Please note, this lesson is a continuation of what we have learned in grade 8.
Learning objectives. Learners should be able to understand cells and batteries as a source of electrical energy, know the composition of the different types of cells and batteries.
Now that we have our objectives, let us get into our lesson.
The cell as a converter of energy. A cell is a device that converts chemical energy directly into electrical energy. In an electric cell, an electrolyte reacts chemically with two electrodes, making one positive and the other negative. A number of cells grouped together will form a battery. Only similar cells can be connected together to form a battery. The essential components of either a primary cell or secondary cell are two electrodes of different types of material, an electrolyte, and positive and negative terminals or poles that are connected to the external circuit. The electrodes are made from chemicals that cause the electron to be transferred from one point to another. During the discharge process, the anode is the electrode that releases electrons while the cathode absorbs electrons. The electrolyte, which is a conductive liquid, completes the conductive path between the electrodes of opposite polarity. Cells can be divided into two categories: primary cell and secondary cell. Primary cells. Primary cells can produce current immediately. An electrochemical reaction occurring in the cell is not reversible, which means that the cell cannot be recharged. Primary cells are batteries that are designed to be used once, then be discarded or thrown away. They are most commonly used in portable devices. Generally, primary cells have higher densities than rechargeable batteries, but they do not perform well under high current or drain applications. Different types of primary cells: carbon zinc batteries, alkaline batteries, mercury batteries, silver oxide batteries. Cell voltage, properties, uses. Carbon zinc 1.5 V, most popular cell. Voltage falls as current increases, best for low current use. Cheap torches, radios. Alkaline 1.5 V, voltage does not fall as much in use, better for higher currents, lasts longer than carbon's zinc cell. Medium price, radios, calculators, camera, flashes. Mercury 1.35 V, voltage very constant until discharged, good in low current use, large capacity for size, long shelf life. Expensive watches, calculators, cameras, hearing aids. Silver oxide, 1.5 V, similar to mercury cells, same as for mercury. Alkaline cell operation. Alkaline batteries are non-rechargeable, high energy density batteries with a very long lifespan. The electrolyte used in this battery is alkaline, potassium hydroxide, hence the name alkaline batteries. The typical voltage for a single alkaline cell is 1.5 V. The battery consists of zinc powder as an anode, manganese dioxide as the cathode, and potassium hydroxide alkaline as the electrolyte. The main working principle of the alkaline battery is based on the chemical reaction between zinc or Zn and manganese dioxide MnO2. The fine-grained manganese dioxide or MnO2 mixed with coal dust forms the cathode or positive terminal of battery. The granular zinc forms part of the anode or negative terminal of the battery. A metallic pin, preferably made of brass, is inserted in the middle of the alkaline battery to collect negative charge. This pin called a negative collector pin. Alkaline has the ability to provide high power levels and good service under high current strain conditions. Alkaline cells are now extensively used to power recorders, television sets, cameras, and many cordless appliances. Advantage and disadvantages of primary cells. Advantages: readily available in various sizes, easy to handle and install. Disadvantages: not rechargeable, produce only small current, relatively short life expectancy. Secondary cells. Secondary cells can be recharged repeatedly when the generated electrical energy in the cell is used up. Parts of a cell. Secondary cells should be charged before use. They are usually assembled with active materials in a discharged state. Rechargeable batteries, secondary cells, can be recharged by connecting them to an electrical current, which reverses the chemical reactions that occur during their use. Devices that supply the appropriate current are called chargers. The most generally used secondary cell is the lead-acid cell used in motor vehicles. Lead-acid batteries. Lead-acid batteries consist of 1. A lead dioxide cathode, 2. A spongy metallic lead anode, 3. A sulfuric acid solution electrolyte. These metallic elements make them toxic and harmful to environment. The cell voltage is commonly 2 V each. The composition of the different types of cells and batteries. Battery type: lead acid. Properties: 1. Have a lifespan of about 3 to 4 years. 2. Robust and reliable. 3. Deliver high currents. 4. Wide range of sizes and capacities. 5. Heavy and bulky. Uses: 1. Automotive use, cars, buggies, trucks, etc. 2. Lighting. 3. Uninterruptible power supplies. 4. Submarines. Battery type: deep cycle. 1. Must be completely discharged before charging. 2. Have thicker and stronger plates than lead acid batteries. 3. Can be charged many more times than lead and acid batteries. Uses: 1. Marine applications. 2. Golf buggies. 3. Forklifts. 4. Electric vehicles. Advantages and disadvantages of secondary cells. Advantages: rechargeable, long life expectancy, produce high current. Disadvantages: slow charge rate is recommended, higher cost when compared to primary cells, require maintenance. Care and maintenance. For the primary and secondary cells, the following should be implemented. Remove primary cells for the apparatus if it is stored for a long time. Secondary cells and batteries should be regularly checked for the battery water. The lead acid car batteries should be placed in an upright position in a cool, dry place. Safe disposal of cells. Once batteries or cells have come to the end of their life cycles, it should not be thrown into a rubbish bin. However, those batteries and cells should be disposed into the battery recycle bins. On the other hand, when purchasing a new lead-acid battery of a car, one should hand in the old car battery, which is then recycled.
Dear viewers, now that we have come to the end of our lesson, let us recap on what we have learned. Thank you for joining us. Until next time, goodbye.